Myself, Rahul Raj. I'm working as a cloud and DevOps architect for 8 years. So here we have gathered to take a session on Azure Kubernetes Service. So I'll be sharing my screen. Please let me know once you are able to see. In Azure Kubernetes Service, I'll be covering all this way. Like I'll be introducing what is Azure Kubernetes Service. I will give a deep introduction about that. I'll be explaining about how it is working, why Kubernetes is using or why Azure Kubernetes is using instead of Kubernetes. And I will go through a demo and I walk through over how we can create a Kubernetes, what is to be deployed or how can be deployed inside application inside Kubernetes, all the application deployment things. And related to that, I will be explaining about the networking things which we are doing inside the Azure Kubernetes service, or we call it as AKS. And also the storage components, how we are mounting the data storages and how the files are getting stored, how the mounts are taking place, all those things we'll cover. And security parts, how the security is handling, how the access and how it is more secure, how it can be the data to be sensitive data to be secured there. And I'll be explaining about the Active Directory integration with AKS. Also some future enhancements, what all the things we can do as a future enhancement inside AKS, or what are the activities we can perform as a future enhancement inside AKS. So all these are areas which I am covering. And one more thing is like you can, I know that you will be having some questions in between and in between the session as well. So I kindly request you to type the question once you get into a doubt or get into something. Or just hold the question with you and type at the last. So anyway, we will be discussing all the doubts and all the clarification things at the final level, or that 15 minutes before the session to be concluded. So mostly it will be, I think, 12:15. I'll be discussing the things. So if you have some questions, kindly keep in your hand, or you can put it in the chat inside. So I'll be discussing one by one at the last. So entering to the session or entering to the topics. So first of all, I would like to give an introduction about what AKS is, what Azure Kubernetes Service is. So before we go into what an AKS or what an Azure Kubernetes Service, we should mandatorily know that what is a Kubernetes. So ideally, the prerequisite of this session is knowledge in Kubernetes service. But if you don't have a Kubernetes service knowledge, or if you are a beginner or a starter on the Kubernetes service, I will try my maximum to get you transfer my knowledge which I am sharing. So I'm trying to make it like as a beginner to get it understand. So I'll keep it in that level, all the explanations and all. So explaining about Kubernetes is like Kubernetes is an open source platform which is developed by Google. So it is written in Go language, it's Google language. And it is an orchestration tool. So definitely it's an orchestration tool. Orchestration tool means something we can manage with the help of, or with this tool we can manage something. So that is the meaning of an orchestration tool. So it is actually used for managing and deploying a group of containers. So in that case, we should understand that what is a container. So I think like you are all from software development background or kind of a software background. So you might know that how an application can be hosted, or how a simple application can be hosted, like, right? So if you develop something code or something, a page or a website, if you develop some website, for example, you have a home page and you have an about us page, and that is your application. Right. So that application can be deployed inside in several ways. We can deploy this application in a PC or a machine, and we can host it using a lot of softwares like Apache or Nginx or kind of Tomcat, or this software will help us to host the application. So that is one way. Otherwise, we can host our application in IaaS if it is something supporting to .NET and all, or we can host our application in PaaS system, kind of web app service or kind of app service, or any of the PaaS system. So these are the ways for hosting an application. So whenever we host an application, what are the challenges we are, or what are the dependencies we are facing are like, we have to install the related softwares when we are hosting an application. For example, if you want to host a Java website in any of the VM or any of the environment, you should ideally install Java virtual machine there. If your application supports some background DB and all, backend DB and all, you should install DB inside that. Like that, you have to deploy a lot of software when you are when you ever deploy an application or when you ever try to host an application. So that side, the container of that place, the containerization take into make the things more easy. So what is container means, you can host an application by embedding all these dependencies along with that. So what you have to do, like, you have to write a Docker file. The file is called a Docker file, and in this file you need to mention about what are the dependencies you have to go for hosting an application. For example, you need to host a Java application, you need to mention the dependencies, like you need to install Java. On top of that, you need to install that in a Linux environment or a Windows environment. You need to say that there is a backend application called MySQL DB is there. All these things you will mention in a Docker file, and all the things, what are the things to be copied, what are the things to be get variabilized, all those things you will be mentioned inside a Docker file, and you will build that Docker file and you will make it as a container. So this container can be shipped to anywhere. So whenever you try to spin up this container in any of the environment, definitely your application will get up and running in anywhere. So you don't need to bother about what are the behind the scenes or what are the dependencies whenever you host an application. So that is meant by a container. So you can transfer the container anywhere also. So in Kubernetes, what happening, like, it will help you to host a container. So there will definitely a question comes, why I am using Kubernetes for hosting a container? I can simply deploy this container inside a VM or anywhere, right? So if you are deploying a single container or one or two or three container, it is very easy for us to deploy, or it is very easy for us to manage. Think that you have 50 or hundreds of container, and these containers are completely communicating with each other. It will be very difficult for us to manage. You know that in earlier stage, we are following a monolithic kind of architecture. So you know that in the monolithic kind of architecture, all the application or all our entire software system or our entire application, we will be doing as a single junk output or junk deployment file. For example, if we are creating a jar file, it will be a heavy jar file, and we are deploying the complete jar file inside the application hosting server. So that is right now changed, and we are using a microservice kind of architecture. So in this microservice kind of architecture, you know that if you want to deploy an application, we are splitting up this whole big application into small chunks, and we are avoiding the dependencies there. For example, if you have a application, or for example, we can take the case of an Amazon e-commerce website. Amazon e-commerce website have a login page, a cart system, a kind of a pool where all the data are resided, and a payment server. All these things are attached to the Amazon e-commerce system. So think that the payment server got down, or the payment system got down, and the application to be up and run. So the person or the user which is trying to log into Amazon website should not, it is not mandatory that person should go to the payment website. That person still can able to browse all the things. He can look on the items, he can put the items into cart. So in that case of scenario, what is happening, like your entire application will get minimum downtime. Like the people is trying to do a payment system only, or payment will be only getting affected. So the 80% or 70% of your application's uptime is uptime, or people will not get you compliant. So that's why we are splitting up the architecture, or that is a real-time use case why we are splitting our architecture into 3-4 or number of microservices. And using like that. So right now we are in a microservice kind of architecture. So there should be lot of containers or lot of Docker containers will be, or if it is Docker container or what kind of container it is, there will be lot of containers for deploying your application, and those containers should be dependent or should be independent, and we have to manage the networking, we have to manage the security side, all those areas we have to manage. So there should be definitely a managing tool ideally we require. There comes the use of a Kubernetes service. So what is AKS doing on top of Kubernetes? So AKS is managing the Kubernetes cluster, or AKS is a managed Kubernetes cluster. So for operating a Kubernetes cluster, people who worked in Kubernetes should know, or if you're not working in Kubernetes cluster, if you don't have any knowledge in Kubernetes cluster, so deploying a Kubernetes cluster will be always a headache. You need to deploy the Kubernetes cluster inside some of the VM, and you need to manage the Kubernetes cluster as well as you need to manage the deployments. So two headaches you need to or two operational things you need to bother about. One, you to manage the Kubernetes cluster, another is you need to manage your application deployment, application balancing and all. So when a time comes you need to scale your Kubernetes cluster as well as scale your application side, you need to manage both. So here comes the beauty of or advantage of the AKS or Azure Kubernetes service we are using. The management of the Kubernetes service or management of the Kubernetes cluster is completely handled by Azure or Microsoft, and we don't need to bother about that, or we don't need to bother about the operational cost of managing a Kubernetes cluster. That's why we are ideally using an Azure Kubernetes service. So Azure Kubernetes service will be a hosted Kubernetes service, and all the critical tasks or the health monitoring of our Kubernetes cluster will be maintained or will be handling by the Azure or the Microsoft people, and we don't need to bother about that. It will be completely a PaaS or a platform as a service we will be getting. We are only bother about the deploying of our application side. Okay, so here comes the introduction of AKS. What is an AKS, or what is a Kubernetes service, and what is AKS on top of Kubernetes service? These two things I have explained. And coming of working of an AKS. So working of an AKS, this diagram will show you that how the AKS cluster or how the Kubernetes is working. This is ideally architecture diagram of Kubernetes cluster. Actually, why I included, like, I want to just go through you to the architecture so that you will understand what is the basic working of AKS or what AKS is exactly doing. So ideally, Kubernetes cluster have two areas. One is the master part, other is the slave or the worker part. So master part is the heart of Kubernetes cluster. Inside the master part, you will see scheduler, API server, controller manager, and etc. These are the parts comes under the Kubernetes cluster master side. And in the worker side, you can see kubelet, service proxy, and there are some applications deployed and some nodes are there. So there will be two parts. One is the master part and one is the worker part, or we call it as a slave part. So this master part is completely handled by Microsoft. In the case of AKS, we don't need to bother about the master part. So if you are directly hosting a Kubernetes cluster, on-premise cluster, or you are managing the Kubernetes cluster in your environment, you need to bother about the master part, and you need to bother about the scaling up of this master part, managing of this master part. So that particular operational cost as well as the headache will be completely reduced when we are going into an AKS cluster model. So you might know that the master part comes with the scheduler, API server, controller manager, and etc. So the scheduler will be helping all our pods and all our application hosted to schedule and manage the deployments and all. API server will be communicating with the Kubernetes cluster and handling the communications between both master and slave node. Controller manager will be controlling with the help of scheduler. etcd will be using for all the key value pair, and it will be helping mutually working with scheduler and control manager to host particular application. So all these basics will be comes under the Kubernetes architecture. So if you are new into Kubernetes architecture, just go through the Kubernetes architecture, you will get more idea. But what I am trying to convey you that if you are using AKS, you don't need to bother about the master part. You only need about the need to bother about the worker part. So what are the things comes in the worker part is you have to take care of your application deployment. Means you have an application, and application you have written already. You have written a Docker file and you have Dockerized it, and it's a container. You need to deploy your container. You need to manage your container. You need to manage the network side of the container. So this will be you as a user. You need to connect to the master node, the worker node, and you need to manage the deployment. You need to manage the networking side. You need to manage the nodes, or the these words will be these nodes, ports. These words will be initial time. Sometimes some people will be inside as a beginner, will be new words for this. Just kindly note these words. I'll be taking these words in another slide. So just as a heads up, I just said. So what I explained, like there will be master node and a worker node, and master node is completely managed by AKS, and worker node is where we are deploying all our application. So this master node health and monitoring will be managed by Azure, and only the agent node or the worker node or the slave node, what we can call in different ways. The agent node only we have to manage, and the master node is completely free for us. Only we need to pay for the agent node what we are creating. The cost will be coming for only the agent node or the worker node part. Okay, and the features actually getting for AKS, or if we are using AKS, the main features we are getting are, it will be simple for us to deploy and manage. Even though AKS is a Microsoft service, it will be easy for us to integrate AKS with CI/CD pipelines and all. So especially in the case of Azure DevOps, you might use Azure DevOps. It will be easy for us to integrate Azure DevOps with AKS and deploy our application. Since it's both are Microsoft tool, it will be very convenient for us to deploy and all. If you are not using Azure DevOps, or if you are using another tools like GitLab or Jenkins or some other CI/CD platform, also it will be not a bigger task to connect with Kubernetes cluster. You can simply write some service connection and connect to the Kubernetes cluster and deploy it. So definitely AKS will be very easy for us to deploy and manage. Identity and management, IAM. So even though this AKS or the Azure Kubernetes service is handled and managed by Azure side or Microsoft, it will be very easy for us to engage or integrate the Active Directory. So if in your organization there will be an Active Directory is using, you can easily connect the Active Directory with your AKS. Since both are Microsoft tools, it will be very easy for us to connect, and you can give rollback kind of permission to your Kubernetes cluster. For example, in your team, some are developers only require the default user or the reader access, or kind of they only require the contributor access. They don't require the admin privilege, or those kind of access you can easily and simply manage using the RBAC policy or RBAC set of rules inside the Active Directory. So it will be very easy for us to manage the identity. And coming to the logging and monitoring, that's also you can use the Azure monitoring system, or you can use the external monitoring tools like of Datadog or kind of Grafana, Prometheus kind of tools, and you can easily integrate your AKS cluster and collect the log and check the and create alerts and monitor it. And coming to the cluster node scale, I already explained about the node part. Node part will come on the agent node or the secondary side or the worker part. So this worker side, and we have to manage about, or we have to think about the node scales. For example, you have hosted an application. For example, you are the person who are hosting an e-commerce application, and there will be sale happening on a particular week. So that particular week, you need to scale up your application's load and all. So in that kind of situation, if you are using a Kubernetes cluster, you should ideally manage about both the master side scaling as well as the cluster side or the secondary side scaling. So when it comes into the Kubernetes, or when it comes into the AKS, Azure Kubernetes Service, we can auto scale all these things with the help of UI side, as well as we can just configure according to the scaling and all with respect to the load. So that also will be very easy when we are using Azure Kubernetes Service. And coming to the node update, you know that, or you might aware that nodes are actually virtual machines or VMs, or a normal Windows kind of or Linux kind of machine which is hosted behind the scenes. So these machine will work only with some OS, operating system, and this operating system require a day-to-day update or kind of patching and all. All these will be handled by Azure itself, and we only need to bother about the we don't need to bother about the patching or the software update of that. So whenever an update came in, you need to refresh your particular node, or you need to recreate the node. The update will be automatically fetching inside your node or the VM side. So these all are the features which we are getting if we are going for a AKS instead of Kubernetes service. You will get all these features in the PaaS system. So coming into the next slide, I'm right now going to create you an AKS cluster with the help of Azure Portal. And I'll be showing you a simple Docker image, how to write a Docker image. Maybe people joined here might not aware of how to write a Docker image. So I'm taking few minutes, and will quickly show you how to write a Docker image and how to push that image to the container registry. So I'm using here ACR as a container registry. So this will be more quicker. And I'll be just I'll be giving you a walkthrough over the AKS using a tool called Lens. You can easily identify, or you can easily get an UI pictorial view if we are using a tool called Lens. So I'm using here Azure. I have taken an Azure Portal, so I'll be sharing screen again. Hope you are able to see my screen. Okay. Yes. Okay. So I am right now in an Azure Portal. So I have taken a free subscription. So here you can see a Kubernetes service option is listed there. So otherwise you have to go here and take the Kubernetes service by typing here. You'll get a Kubernetes service option here. So once you click on the Kubernetes service option, we have an option showing create. Here you need to click to the create a Kubernetes cluster. So since I am using a free trial, I am clicking my subscription as a free trial. If you have some other subscription already subscribed by you, you can use that. So resource group is ideally people who don't know about what is a resource group, who is new to Azure Cloud. I can say like resource group is nothing but a kind of a separation or a classification we are creating here, kind of a folder we are creating, and some logical folder or logical kind of classification where we can classify in different ways. Like we can classify, we can create a dev resource group and put all our dev resource inside a dev resource group, or we can create separate resource group for AKS, ACR, VMs and all. So resource is nothing but a kind of a folder, a kind of logical classification. So I have already a resource group here that's called an AKS resource group. If you don't have a resource group, you can create a new one while creating this cluster. And you have to give some cluster details or cluster classification. I'm just giving dev test since I'm using a free trial. I'm just giving a dev test, and I need to give a Kubernetes name here. So I'm giving AKS for steady. That name is available. Yeah, that name is available. I need to give a region here. So you should select some region that is near to your working location or your infrastructure hosted wherever according to your convenience. So I'm just giving East US as the region. And coming to availability zones is nothing but it is giving you a high availability or HA feature inside the Kubernetes. Like availability zone will be, you know that all these Kubernetes cluster you are creating will go or will reside inside a data center. So here we have 3 zones the data center is hosted. So whenever first availability zone or zone 1 is not available, it will automatically you can able to get your Kubernetes cluster in from availability zone 2. Like that, you can select all these 3 zones if you require according to your software requirement. You can host the Kubernetes cluster availability zone. Now I'm choosing just none because I don't since I'm creating it for study purpose. I don't want my Kubernetes should be available all the time. So I'm taking that risk. And coming to Kubernetes cluster version, Kubernetes cluster version will be connected to the Kubernetes cluster open source thing. So the version which is available will be automatically available here when Azure people puts or linked with the Kubernetes version. So always choose a default version whenever you are creating. That is the best practice. Or you can take the latest version. This version will be automatically changing day by day. Like in 2 or 3 weeks, you can see the latest version coming here. So you can choose a Kubernetes version here, and you need to choose a node size. So node size is nothing. I have already explained the word inside this diagram. So node size is the VM size or the Kubernetes. This Kubernetes cluster will be behind the scenes. There will be a virtual machine running, and we need to point the what kind of virtual machine or what configuration of virtual machine you require. So since I am using a free trial, I'm going with the least configuration, that is 2 CPU, 4 GB RAM, and 4 GB data disk. And this is the processor size and the cost, which is the least cost. So I'm going with the least node size. And scale method will be, I am putting, instead of add auto scale, I'm putting as manual, since I'm not going to do a bigger operation here. And node count, you can choose any node count according to your cost and according to your requirement. So I am just choosing here node count as 1, since I don't have much operation, or only I am just going to try out a simple demo application deployment. So these are the initial basic configuration I have done here. So going to the next stage, that is a node pool. I already chosen the node here. So here you can see an agent pool got created. That is the same B2S configuration which I have configured here. So once I configure here, it will automatically reflect inside the node pool. And you can see the node pool mode as the system. So there will be 2 modes available. One is the system node pool and other is the user node pool. So we will call it a system pool and user pool. So system pool is definitely whenever you are creating a Kubernetes cluster inside a PaaS platform or inside AKS, it should ideally require a system node pool. And in this system node pool, all the kubelet thing, all the Kubernetes worker node things will be creating. So if you remember about the diagram which I shown earlier, you can see like inside our node, there will be kubelet and service proxy. All the networking related things, all the DNS configuration related things will be residing. So whenever you're creating a Kubernetes cluster, all these kind of worker node data or worker node system settings will be creating automatically inside the system node pool. And you can also deploy your application inside the system node pool. It is not mandatory that you should not deploy there. You have a little bit space available still there according to the node size you're creating. You can also create application inside this into the rest of the space. Also, you can create a user node pool whenever, if you are required, like just add a node pool here and add another node pool as a user node pool, and that will be completely managed by you, or it is not like you can switch here whatever you require, system or user node pool. So why this system node pool or user node pool kind of differentiation? Because okay. So why this kind of differentiation? Because system node pool is ideally required. There should be one system node pool, and user node pool you can create n number of user node pool. Also, you can create n number of system node pool, but there should be definitely one system node pool which will handle all the system activities. And if you want to change the system node pool, tomorrow you want to increase the size of the system node pool to B2S instead of a bigger size. If you have a user node pool available, you can switch the system node pool from system to user, and you can arrange a temporary kind of user node pool into system node pool, and you can change your size accordingly, and you can switch back to the older node as the system node pool. Like like if there is user node pool already available, it will be easy for you to manage anything in the system node pool. Like you can switch, or you can switch those node pools if you have some issues in if you see in the Kubernetes cluster and all. So there will be best practice will be always create a user node pool and deploy your application inside your user node pool. Do not use system node pool for your application deployment and all. That is the best practice we are following. So that is just I am added up along with the deployment. And enable virtual nodes is another feature which is given by Azure Cloud recently. So that is you can host or you can create a virtual nodes like a container instance inside this. So additional feature which is given by Azure recently. Going into the next access level. So there will be authentication type we can specify. There will be three kind of authentication type. One is the local account with Kubernetes RBAC. Other two are with respect to the Azure AD. So local account, you can choose if you want. You can choose local account, or I already explained like you can integrate your Azure AD with that. So if you have an Azure AD, your organization using an Azure AD, you can integrate your Azure AD here. Or if you are using Azure AD and if you want to use the RBAC rule, which is specifically you are mentioning inside the Kubernetes cluster side, you can use this. Or you are using the Azure AD and RBAC also, if you are using in the Azure side, you can choose this option. So I am right now going with the local account and local RBAC rules. Next, going to a networking side, there will be two ways you can create the network. One is a KubeNet, other is the Azure CNI. So KubeNet will be the internal networking which is we are using inside the Kubernetes cluster. Azure CNI is another feature which we are getting, since we are using AKS or Azure service. So Azure CNI is nothing but the network will be handled by Azure Cloud itself. So the main advantage, since if you are using Azure CNI, is like people who already have experience will only understand if I am speaking this. So if you are using Azure CNI, your pod will get, or if you can assign your pod some IPs from the subnet you created. So that is the advantage mainly if you are using Azure CNI. And KubeNet is an internal networking thing, since you can classify, like you can create it will automatically create a virtual network inside your Kubernetes cluster. And you can go in both ways. Right now I am going with the KubeNet side. And if you have chosen the Azure CNI, you will get a network policy of Azure you can choose here. If you are not choosing Azure CNI here, you cannot able to choose a network policy Azure here. That's one more advantage if you're choosing Azure CNI. Okay. One advantage I said, like you can also use the pod IP as the IP from your subnet. That is the one advantage if you're using Azure CNI. And other advantage is like you can use a network policy as Azure. Okay, so if you're not using Azure CNI and if you're using KubeNet, you can choose network policy as Calico or none. So network policy is nothing but a set of policies which is already written, and standards which already kept, and these standards you have to follow. So Calico is an open source standard, network policy standard. You can choose if you require, or you can go with none. So I am right now going with none. And yeah, these are the networking side. And if you want to enable your network as a Kubernetes cluster as a private cluster, which should be accessed inside only in your organization virtual network, you can enable the private cluster. But I am right now not created any virtual network, or I don't have any virtual network. I'm just used for demo purpose. I'm not enabling it. But if your organization requires your Kubernetes cluster should be inside the private network, should be completely inside in your organization network, you can enable this option. And coming to the next integration. So here comes the integration of container registry. So container registry is nothing, a registry which you can keep your Docker images and store there. So right now I am using Azure Kubernetes service. So I am using an Azure container service, which is called an Azure container registry. So while the time of creation of this Kubernetes service, I'm just pointing out my already available Azure Kubernetes registry or Azure container registry, which is called ACR for steady. And I am integrating that along with this. So the main advantage while creating a Kubernetes, if you integrate an Azure container registry, you don't need to give the permission for this Kubernetes to access this container registry. So if you want to push some image, or if you want to deploy some image which is already available in this container registry, you don't need to explicitly give permission for this Kubernetes cluster to access. So while the time of integrating, it will automatically create the permission. I will showcase you once the Kubernetes get created. Then coming to Azure Monitor, if you want to enable it, you want to enable the monitoring things and all. Also the Azure policy side, you can enable the policy if you want to enable the Azure policy here. And coming to the advanced option, so whenever you're creating an Azure Kubernetes service, AKS, there will be an infrastructure resource group automatically created. So infrastructure resource group is nothing. It is a resource group contains all of your backend activity or backend resources for a Kubernetes cluster. For example, whenever a AKS cluster is created, there will be automatically a private DNS, a private IP, or a public IP, and Azure managed identity. All these things will be automatically created along with this Kubernetes service. So these automatically creating things will go inside the infrastructure resource group that you can name according to your wish. Right now I'm using the default namespace name thing, MC underscore resource group. MC means managed cluster. So I'm just using this same name. Coming to the tags, you can write anything like if you want to use created by who, to know that who created this Kubernetes, you can use any tag name according to your wish. Coming to review plus create, so it will review the complete and validate the options we have given. It will take a minute. So validation is passed. So I'm going to create my Kubernetes cluster by clicking the create button. So this Kubernetes create operation will take 5 to 10 minutes mostly. So in meantime, while creating the Kubernetes cluster, I'll just showcase you how to create a Docker image. So the people who has no basic information about how to create a Docker image and who wish to know what is happening behind the scenes, I'll quickly show you without taking much time. So I have a simple HTML project here. So this is my HTML project. And I have written a simple HTML file. So this HTML file will do a simple operation like there is a title written and a body alignment written and a heading H1 written as welcome to world of DevOps, and a heading H2 is written. Some data is only written, and one image is also pointed. So whenever you take this HTML file, you will see all these things. That is the only single thing which I have written. And this image AKS.jpg already pointed here, and the location is also pointed inside the index.html file. So I am just going to build this particular index.html file using Docker file. So I have to write a Docker file here, and this Docker file will say that what are the things to be included while the time of building. So I am including from Nginx here while the time of building a Docker file, because you know that this is an application called HTML. So this HTML application requires some background application to get up and running or hosting. So I am using Nginx here. So this container, or this, whenever I build this particular Docker image, it will containerize with the help of, or it will download the Nginx from the Nginx website, and it will copy HTML, the contents inside the HTML folder. You can see the HTML folder here. So all the contents inside the HTML folder, that is I mentioned as star, and it will copy to the containers location. So whenever you are creating a container, it should be automatically have some memory, and inside that container, all the files will be get copied. So I'm building this simple Docker file with the help of a Linux machine. So all the source code I have just put into my GitHub repository. This is my GitHub repository, and the source code I just cloned into a Linux machine. Okay, and in this Linux machine, I have installed Docker software already here. I will share the Docker software installation link and all. I can install the Docker software using. I'll show you the link. Yeah, this is the Docker installation commands and all. You can install the Docker using these commands. I will share you the link once after the presentation is over, or once after the session is over. So I have already installed the Docker image, Docker to Docker software inside this Linux VM. You can see, like, whenever I type Docker, I can able to list all the Docker related things. So Docker is installed this, and I have already installed Git inside this. So Git, whenever I type Git and enter, I am getting Git commands or Git response. So I have cloned this source code from my Git repository, this Git repository, and I have copied all my source code here. So I can simply build this Docker image. So I need to go to this particular folder structure. Okay. So this is the folder structure, project image and project simple HTML. So I'm heading to project simple HTML, cd space change directory space project simple HTML. So here you can see the HTML folder which I shown you earlier, and the Docker file. This is already I have shown you the HTML folder and the Docker file. And Docker file contains these things. Can just verify it. I am using cat command and I'm just verifying. Yes, the contents are displayed already written inside this. So I just want to build the Docker file. I'm using the command called docker build space dot means what is the dot means the current directory or current location. So what are the Docker file already set in the current location will be automatically taken. Minus t means tag name. I have to give some name for this image. I am giving a sample image colon 1.0 colon 1.0 in the sense it's a version name. If you are not given any version name, it will automatically take the version name as latest. Okay, so I just want a version name, so I'm giving 1.0. So I'm going to build this particular image here. Docker build dot minus t simple image 1.0. You can see the Docker image got built here. So first step from Nginx, it downloaded from Nginx and copy the HTML file and all the things done, and the Docker build has done successfully. And you can see like the already tagged to simple image 1.0. Okay, since I have already done this image previously inside this virtual or this Linux machine, it happened in a single it's a microsecond or within 1 second. If you are doing this first single time, it will take some time for getting this Nginx image from the cloud or from the Nginx website, and it will take some time for copying all these files to this folder. Okay, so since I have already done it, created very fastly, and I can see the Docker image here using docker image ls command. I can see all the images here. The image which I created, I have tagged as simple image 1.0. So you can see simple image 1.0, simple or sample. Okay, sample image 1.0. So you can see like sample image version tag as 1.0. So that is got created. So I want to try, or the image is already available with me in my system. So I want to try to host this inside this vMachine. I want to spin up this application. So I will use a command docker run -p port. I need to mention. I want to expose it in HTTP port, that will be 80, and I need to give the invert port or the internal communication port, that will be also 80, and I need to give -d as to detach. I will explain you what is a detach, and I have to give the name of the image. Okay, so this is the command to run a Docker image inside my local machine or a Linux machine. So once I run this, you can see like docker run -p 8080 -d simple image 1.0. Once I run this, I will get a tag number. So this tag number is nothing I have given like -d command. So detach this. If I didn't give this -d, I cannot move this page because all the logs will come here and the instance will be running in this session. So right now the session has go to detach mode, and you can see the session using Docker container ps command. You can see 8D93. This image is running, and it is hosted to 80-80, and this name will be automatically defaultly there will be some name coming in and created in 35 seconds before. Okay, so we can check that whether this image got created or not. So for that, this is a Linux machine. I already told you that this is a Linux machine. I have created this Linux machine in my Azure portal. So yeah, my AKS already got created. Okay, I will come to that later. So I have the Linux machine already available. You have to go to the virtual machine option. So there is a VM already created, VM for steady. Okay, so I want to check that whether this HTML page got worked or this container is up and running. For that, I will take the IP of this particular virtual machine. Okay, I need to go to the overview page. Here you can see the IP of this virtual machine. I need to copy this IP, copied, and I will go to the browser and I will type the IP, and I will give HTTP : here / yeah. So my container got up and running here. So this is the HTML page which I have already created. Welcome to World of DevOps. You already seen the codings here. HTML, index.html. The same thing I have hosted here. And if I make this container down, I can use a command called docker kill and the container ID. Container ID is starting with 89. Yeah. Docker kill the container ID. My container got killed. Now you refresh this page, you will not get that website because the container I have killed. So this is the way how we can simply build a Docker image, deploy or spin up the Docker image. So here it is only one single Docker image. It's very easy. So coming to a microservice kind of architecture, there will be 100 Docker images will be hosting, and it will be very difficult for us to manage a particular system, entire system. So that's why we are using Kubernetes ideally. And for making the Kubernetes administration more easier, we are using the AKS cluster here. Okay, so my AKS cluster got created. So yeah, go to home. Okay, here you can see like my AKS cluster got created. I will go to the Kubernetes services. You can see AKS for steady got created. And you can just check what are the things I have created. Okay, portal is taking so much of time for me. Okay, so you can see like Kubernetes version which I chosen, the location, the name of the Kubernetes cluster, the resource group where it got created, the networking thing, it took KubeNet, automatically took the IPs and all the things which I have given there. It's automatically got created there. And also I already explained you that there will be a resource group which is holding all the infrastructure. I will show you that resource group. Before that, I will just quickly show you this thing. This is the API server address. I have explained you in the presentation that in master node there will be an API server, and this is the API server address which is connecting to the API service. So whenever you are deploying a Kubernetes cluster in a PaaS environment, your kubelet will be communicating to this API server as a master node. This master is hosted by Azure or the Microsoft. So this is the address for this API server. You can see here. This is automatically created. And yeah, I will show you the infrastructure resource group, which is automatically created by the Kubernetes service. You have to go to home. You have to click the resource group. You can see a resource group start with mg_. Yes, that's available. This is a resource group that automatically got created by the Kubernetes cluster. So we will check what are the things available inside that cluster resource group. Yes, there is a public API already available. A VMSS got created. Yes, one VMSS got created. VMSS is nothing. It is a virtual machine scale set. It's a combination of virtual machines. It's a cluster of a group of virtual machines. And NSG got created, route table got created, virtual network got created, a managed entity got created, and Kubernetes load balancer also got created. Okay, so so here, if you go to the VMSS virtual machine scale set, you can see this is the system pool we have assigned. Okay, so this is a B2S configuration you can see here, and all the things B2S, 4GB, 2 CPU, the same thing. So this is a virtual machine ideally. So this is the node is equivalent to a virtual machine. And coming to coming to agent pool or manage entity, I already explained you when the time of creating a Kubernetes cluster, I have added ACR or the container registry along with that. So that because of that, a manage entity got created. And if you check in the Azure role assignment, you can see an ACR pull role automatically got created for ACR for study this container registry. So if you are not integrating this container registry along with the Kubernetes cluster creation, you need to go to a Kubernetes cluster, and or if you are not using Azure Container Registry, if you are using Docker Container Registry, or if you are using AWS Container Registry, ECR, and all, or you are using Google Container Registry or any of the public or private container registry, you need to create an ACR pull access and you need to specify the credentials here. Then only your Kubernetes cluster can pull the images from there. So this is a feature given by AKS. By the time of creating a Kubernetes cluster, you can integrate your ACR or the container registry along with it. Okay, so just want to showcase you these things. And you can see a load balancer here. So why the load balancer got created? Because we have unchecked the option called enable private network. So if you disable the private network, that means it is in public network. So there will be definitely a public private IP got created. So you can see here, public private IP got created. If you have chosen private network, it will not create a load balancer for here. Or if you will not create a public IP for here, since you can see a public IP address here. So all these details I want to just showcase you or just cover you, and I will show you how to connect into this Kubernetes cluster and how it is AKS make more easy for you to connect to Kubernetes cluster. So for that, what you have to do, like you need to install two softwares. One is Azure CLI. I will give you the links. This is Azure CLI link. I will share you. So you need to install Azure CLI in your machine. If it is Windows machine, you need to install Azure CLI for Windows. Since I am using a Linux machine, I am just showing you with Azure CLI for Linux. And you need to install kubectl. kubectl, you can download it from the Kubernetes website. Anyway, I will share you the link at last. So you need to install kubectl. So using these commands, you have to install in your, if it is a Windows machine, you need to go for the Windows installation setup. If it is a Linux machine, you can go for the Linux setup. Okay. So I have done already these things, installed kubectl and installed Azure CLI. And the first thing I have to do, like I need to go to my mission. So this is my mission. I need to give AZ login to my Azure Cloud. So once I give AZ login, I will get a URL for device login. I need to copy this URL. I need to paste it in my browser. Okay, it will ask for a code. That code is also, you can take it from here. Paste the code. It will ask for you to authenticate. So this is my address. Already I have since I have already logged in another Chrome session, I will take it will take the cache session from there. It will automatically authenticate. If you are using the first time, it will automatically ask for the password. You have to give the password, then it will get authenticate you, and you can see it is authenticated. You can see the cloud and all the things has listed here. Okay. So now what you have to do, like, you need to go to the Kubernetes cluster. This is your Kubernetes cluster. Okay. So here comes the beauty of AKS. AKS or Azure Kubernetes Service will give you or will guide you how to connect to your Kubernetes cluster here. So once you landed in Kubernetes cluster page, you can see a connect option. Click on the connect option. There will be some commands listed here. First, it is saying to set the subscription. So you know that in Azure Cloud, you will have a lot of subscription. So subscription depends on your organization, how they are paying and how they are buying from the Azure Cloud. So you need to choose your subscription here. Copy that command, paste it here. You will be setting that subscription. If you have 10 subscription, you need to mention that which is your subscription you are going to take this Kubernetes cluster. So that's why I'm setting the AZ account set subscription command. Using this command, I will setting the subscription. And there is another command called AZ AKS get credential. Okay. So AZ AKS get credential. So I am copying this command. I'm pasting here. Once I paste it, it is saying like AKS for steady is merged in some file. Okay. So this is part of the kubectl. Okay. So once you install kubectl in your machine, it will automatically create a .kube folder inside your machine. So .kube folder will always reside in your user directory. So here you can see like in home DevOps admin folder, .kube is residing. If you're using a Windows machine, it will always residing in C users, your username. Under that, you can see a .kube folder in hidden folders list. Okay. Inside .kube folder, there will be a config file listed. Okay. So inside that config file, your credential is automatically got entered. That means you can just go to this config file and see that whether this config file, okay, you can see, yeah, your AKS for steady, this mission got embedded here. Okay. 1 second, I will cd space .kube folder. I'm just removing this config file from here using rm command. Okay, now you again give the same command which we copied from Azure Cloud, is an AKS get credential. You can see like it's again given me that message. If you go here, you can see the config file is again created. So it is automatically happening, or it is automatically creating by your Kubernetes cluster, since you have already installed kubectl in your machine. Okay, we just cat it, cat config, we'll get the whole configuration listed here. So from API version v1 until down, you will see the credential of this Kubernetes file. So if you share this particular config file to anyone, so that person will get the same access of you what you have tried to connect to the Kubernetes cluster. So you'll get the same access for that config file. So that's a security thing. So you should not transfer the config file to anyone, so that they can also connect to your Kubernetes cluster easily. Okay. So right now I got the config file. So I am trying, or I am checking whether I have connected to the Kubernetes cluster or not. So for that I am using kubectl command. Okay. kubectl or kubectl, anyway you can call. Kube control, anywhere you can call. So kubectl get all the commands, or most of the commands will start from the get operation. So kubectl get -a. Sorry. kubectl get ports -a. So I want to list all the ports inside the Kubernetes cluster. -a means all, everywhere. Okay, so I understood that my Kubernetes cluster is got connected, and I can see all the ports here. Don't wonder about what is a port. I will explain you about what is a port if you are not known about what is a port. So people who know about port, so these are the ports which is already inside the Kubernetes cluster. So this is an empty Kubernetes cluster. You all know that I just now created. So you can see that all the ports are residing inside the kube system namespace. So what I explained you earlier, we will create a system node pool initially. So that system node pool contains of all the worker node related things. I already shown you in the PDF PPT, this kubelet service proxy and all these things will be automatically created inside the system node pool. So this networking things and all, this is part of the AKS cluster creation. So you can ensure two things. One is you are connected to a Kubernetes cluster using kubectl command. Second thing is all the kube system related things is automatically created and the pod is up and running. Okay, and you see namespace here. Namespace is nothing. It's a virtual classification which you can apply in your Kubernetes cluster. So namespace means you can divide your Kubernetes cluster. For example, you are using your Kubernetes cluster for dev activity and QA activity. Okay, so you can create two namespace called dev and namespace, dev and QA, and you can deploy your application which is related to development environment, which you can deploy in your dev namespace, and you can deploy all the activities or all the application related to QA in the QA namespace. For example, whenever a new developer comes in and he wants a separate namespace and he want to put all his testing application inside that namespace, he can simply create a namespace with the command kubectl create namespace or ns. His name, my name is Rahul. I am creating with Rahul. So you can check kubectl get namespace or ns and press enter. We'll get all the namespace here. You can see the Rahul also listed here. So I can deploy all the application inside Rahul namespace. Since I am a new developer and I am testing all the new application in my own space, I can deploy all the application here. And if I am thinking like tomorrow I don't want all these application I am my testing is over, I can go to a dev and deploy all the things. So I'm just going to delete this namespace itself. So all the application inside, what have you done? You don't need to go and delete all the application one by one. Instead of that, you just need to delete that namespace using the command kubectl delete ns, the namespace name. Once you give this, the namespace Rahul got deleted. So this is the advantage of namespace. This is a virtual classification. Okay. So coming back to the Kubernetes cluster, right now I have used these commands and connected to the Kubernetes cluster. Okay, so you can see here Kubernetes resource also displayed here: namespace, workloads, service ingress, storage, configuration. I'll explain you all these things, but these things you can see these ports deployed. This application got deployed in a beautiful way, in a better UI way, using a tool called Lens. Okay. This is a tool called Lens. You can view all these things and you can do operations using this tool. So if you want to install this tool, just Google Lens space Kubernetes. You can see the Lens IDE website here. You can install from here and you can connect your Kubernetes. So how you want to connect your Kubernetes is you take the config file from here. You can take the config file. You have to copy the entire config file, okay, until the token, and go to the tool called Lens. Click here, go to the file option, add cluster, paste all things you have copied and add cluster. So you have successfully added the AKS for steady cluster here. So once you click on this, you'll get auto connected to the Kubernetes cluster. So this will give you more pictorial way or more graphical way how the application got deployed, and you can also do a lot of things here. You can do terminal things, you can do troubleshooting, you can see the logs, you can enter into the cluster or you can enter into the pod. You can do a lot of things here. This is a good tool. So you can see, go to the pods here. I have listed all the ports using my commands, right? Earlier. Now I can list all the ports. See here, the kube system namespace, I have listed all the ports here. The same command I have used here and displayed all the things. Instead of that, I think the recording has been stopped. Is there any problem?
We'll check, Rahul.
Okay.
Please continue.
Okay, thank you. Okay, fine. So, yeah, though those ports are got created. Sorry, those ports we can see here in the this tool, Lens tool. So, Lens tool is a good tool. You can see all the ports deployment. I will explain you all these things what it is, but you can just see all the things: configuration, networking things, storage, all these things in a pictorial view. Okay. So, coming back to the slide. So I have created an AKS using Azure portal. I have created a sample Docker image and pushed to ACR. Sorry, I didn't push to ACR. Okay, I have created a sample application and I can push this to ACR easily by, so I will explain you about what is an ACR. So here, if you go to the Kubernetes or Azure portal homepage, you can see the container registries here. So inside the container registry, I have already created a container registry here. Okay. So this container registry, you need to push your particular images. For that, you require the access key. You need to go to the Linux machine using the command docker space login. Then you give the container registry name, that is login server name, then give enter. Since I already connected, it will not ask me for username. It will check the authentication credential is correct or not. If you are connecting the first time, once you give this, it will ask you for the username and password. You have to give the registry name and you have to give the registry password. Both are there. You have to give this. Once you will give this, it will login succeed. Then you push your image to the container registry. So for pushing your image to the container registry, you should always tag your container registry image with, or you should always tag your image with the name of the container registry in starting. For example, Docker image ls will list you all the images. So you can see here, I have named my image as ACR for steady.azure.zr.io/image upload. So you need to, while the time of building using the Docker image, docker build.that command, you remember that command I used -t tag and tag the Docker image, and I have tagged as sample image space colon 1.0 with the version name. Instead of that, you need to give it as like ACR for steady.azure.azure.io/your image name colon the version name. If you are not giving that, default wise, your image will go to the Docker registry. You know that Docker has already have a public registry. So if you are not giving any registry name in front of the image, it will try to push the image to your Docker registry, since if you are already logged into your Docker registry here. So if you are not logged into your Docker registry, the image will not get pushed. So if you want to push the image to your own managed registry, you should always create the image, or you should always tag the image using a Docker, your Azure container registry, or your container registry name in front of that. So if you forget to tag while creating a Docker image, you can use a command called docker tag the existing image name. So if this is the existing image name, sample image. So existing image name colon 1.0 is the version name, and your new name. New image name will be contains with your registry name as well as your image name. So you can tag the image like this. Once you enter this and you check the Docker image ls, you can see the image got retagged ACR for steady.io/sample image, version is 1.0. So this way also you can retag it. So once you retag it, you can easily push your image. So pushing the container registry will be you have to log into the container is using docker login command. So I already log in, and then you need to give docker push space your image name completely 1.0. So this will say that which registry need to be pushed and what is the image and which is the version need to be pushed. Once you give this, it will start pushing. Pushed. It will push in layers. That's why it is pushing one by one. So now it got pushed. Yeah, it got pushed and created a SHA number. Okay, now you go to a container registry and go to the repositories. You can see the sample image got created here. The version name as 1.0. Okay, so this is how you have to push the Docker image. Okay, so and I have given a walkthrough on AKS and I have given a walkthrough on Lens tool. Okay, then coming to the basics. So explaining about the basics, some terminology you need to study whenever you are studying about a Kubernetes cluster. So if you know of something about Kubernetes cluster or Kubernetes, you will be familiar about these names: pod, deployment, node pool, all these names. So I will explain you with a simple terminology. So pod, or you can say, like, for example, you are creating an application and your application is a website, and that application is equivalent to a container. So right now I have created a container, Docker image. This is my container, and this container, so whenever an image got deployed, will be equivalent to container. If it is not deployed, it will be called as an image. So the static name will be image and the dynamic name will be container. So my application is a container. So I can deploy a single container inside a pod. That is one way. Or else I can deploy multiple containers inside a pod. Okay, here you can see like two pods, pod 1 and pod 2. Okay, I have deployed a single container or simple application in a pod, or I have deployed multiple application in a single pod. So these are different ways. So always remember that one container is not equal to one pod. Sometime maybe one container equal to a pod, or sometime multiple container can be called as a pod. I'll tell you a use case. For example, an application requires an additional container which need all the logs to be catered. So that application will be hosted as application A will be this, and one more application will be we will be pushing, or we will be creating, and all the logs from application A will be transferred to this container. So both containers should be sit inside a single pod. So that kind of use case, whenever it comes in, we require two containers or multiple containers to be sit inside a pod. So those kind of technologies called a sidecar implementation or sidecar pod deployment might be heard of, but I'm just telling you in as a heads up. So that means a single container, one container is not equal to a one pod. Might be two containers or three containers will come with a single pod. Okay, so all the pods, pod 1 and pod 2, can be deployed using a deployment.yaml file or a deployment file. So all the deployments inside a Kubernetes can be done using a YAML file. So we will write a deployment.yaml, and where we will mention that my pod 1 is this, and my pod 1 consists of one container, and my pod 2 is this, and my pod 2 consists of two containers. So that's how I write a deployment YAML, and I will deploy this particular deployment YAML, and my pod will get deployed. Okay, and all these pods will be residing inside a node. So you can see like node 1, node 2, node 3, and node 4. Okay, so like that, I have created a system node pool. For example, system node pool is node 1, and my user node pool is node 2. My second user node pool is node 3. My third user node pool is node 4. Okay, so I am just expanding, or I am just zooming the node pool 4 for my third node pool, third user node pool, or node pool 4. I'm getting this image, right? My pods are deployed in my fourth node pool. Like that, it will automatically, that Kubernetes will play the role that where your pod needs to be deployed and where that control will be taken care by Kubernetes. But you can see like the inside the fourth node pool, you can see the deployment.yaml or deployments, and inside the deployments you can see the pod, and inside the pods you can see the container. And this is a pool. Pool will be same as system pool or node pool. So for example, these all are system pool, for example. So system pool 1, system pool 2, system pool 3, and system pool 4. Okay, not system pool. So VM inside the system pool. Okay, so in a single way or a simpler way, I can say like the collection of VM or a group of VM is called as a pool, and the node equal to VM or node equal to virtual machine. So these are virtual machine 1, virtual machine 2, virtual machine 3, and virtual machine 4. All the virtual machine collectively called as a pool. And inside each and every virtual machine, there will be pod, and each and every virtual machine, there will be deployment, and each and every deployment, there will be pod, and each and every pod, there will be one or more containers. This is a hierarchy will go on. You can see like container will be instance of an application or one or more application. Container is an instance of single application, and pod will be consist of one or more containers, and deployments will be one or more identical pods, and that can be managed by a Kubernetes cluster. And the nodes will be equal to individual VM. Pools will be group of nodes or group of VM, and all we are writing with the help of a YAML file or a manifest we called as. And if we check the manifest, we will came to know that what are the things written or what are things there residing inside a Kubernetes cluster. For example, I will show you a manifest file quickly. So if you come to the project image, you can see YAML image upload. I have written a deployment.yaml. So in this deployment YAML, you can see the kind of deployment. This is a YAML file. This is a manifest file. So by looking into a manifest file, you can understand that what are the things or what are things happened inside that. So inside this manifest file, you will get to know that this is a deployment.yaml file, and you can understand that there will be containers portion. Inside that containers portion, these are the container detail which is given. So if there is only single container given, if there is a multiple container type of way, you can see the same name is giving here like this. If there is two container inside a single pod, it will be listed like this: name AKS container, and another is the second name of the another container. Okay, so this is how we can understand that how a manifest file got deployed. Okay, so these are the information related to pod and manifest file. So these are the components mainly we are seeing inside a Kubernetes cluster: pods, deployments, services, ingress, config maps, secrets, and storage classes. These are the things you will came to see, or I will explain one by one. And the same things you can also see in the Lens tool: pods, deployments, networks, ingress, service, all these things you will see in the Kubernetes cluster as well. Okay, so for better explaining, I will just show you how to deploy a particular application using Kubernetes cluster. So coming into the, I have written a project called project image upload. So in this image upload, I have written using some .NET language. Okay, you can see the .NET CS projects are written here. And I have Dockerized using a Docker file. You can see a Docker file written here, a bigger Docker file than which I shown earlier, like .NET, ASP.NET, all those things are there. Entry point, everything has given. I'm not explaining more detail on this because my session is not Docker. But yeah, but just I already explained you Docker, so you will get it, understand. And so the image upload is the software which I have written. And I have Dockerized it, I have containerized it, and my container is available. And I pushed my image to the ACR. I can take or fetch my image from the ACR, which is shown the same way which I had shown you earlier. Now I have written some YAML files. So these are my YAML file. I have written YAML file for deployments, ingress, service, storage, secrets, and config maps. So inside the deployment, I already shown you the deployment .yaml I have written for this. So with these details, I will be showing you how to deploy an application. inside the Kubernetes. So I have this deployment YAML in hand. I already shown you the container specification we are giving here. So I am just logging you into the Kubernetes cluster. So I am right now in the Kubernetes cluster. You already seen that I have connected there. So I have this particular source code already cloned into my this VM. So I'll go to the home directory, cd/home/devops/admin/ here. I think project is my folder inside the AKS. Okay. Yeah, you can see the project image and project simple HTML. So project simple HTML I have already explained you. Project image right now we are going to deploy. So I will move to project image folder. Is capital, yeah, project image, yeah. Once I list inside that, I can see like YAML image upload, that are my YAML file, which is using for deploying a Kubernetes cluster. Once I get into that, I can see all the folders listed there. I'll go to deployments, cd space deployments, cd space deployments. Okay, so I have a deployment YAML written there. So I already shown you what is written in the deployment YAML. Deployment YAML, I have say the kind what it is, and I have set what is the name of my application, and I will say that the deployment strategy. You might heard of rolling update, canary deployment, and all. I am using rolling update, kind of a blue-green kind of deployment. It will not give you downtime, and I will use a label called AKS image. And this is my container specification. So I will explicitly give what is a CPU and what is a memory which should utilize by my container. And this is the image which I have to taken from this ACR. Okay, ACR for study. This is ACR which I put, and this image is already available. I have already pushed the image. I already built the image using Dockerfile, and I already pushed the image to the ACR. Okay, so now I am going to deploy this particular deployment.yaml kubectl apply -f. This is a command for deploying a particular YAML file, kubectl apply -f deployment.yaml. If I use this, okay, it is given me error that namespace image is not there. So I already told that what is a namespace. So I have to create a namespace called image, because I have configured my YAML to be deployed in the namespace called image. Okay, so image namespace is not there. It's throwing me error. I'm using the command called kubectl create namespace image. Now my image namespace got created. So I am again deploying my deployment.yaml. Apply -f deployment.yaml. So the image got deployed. Okay, so go to the lens, go to the ports, go to my image namespace. You can see inside the deployment, there is my deployment YAML. Yes, it's available there with the same configuration which I have given. Rolling update. AKS name is an image, AKS image, and there is a container running inside that. Yes, I can deploy multiple containers inside that if I want. And if I go to the ports, I can see the port is also deployed. So deployment and ports are different. Ports comes inside the deployment file. Okay. So if I delete the deployment.yaml, the port will also get deleted. If I delete the port, if I delete this port, it will again recreate the port. You can see like that is got terminated, but again one is coming to pending stage. So if you refresh it, you can see that again the port got created. That means this deployment, until this deployment file exists, the port, we cannot delete the port. If we want to delete the port, we need to delete the deployment.yaml. So that means the port got restarted. That's it. Okay, I can see the port here. So this is how we are doing a deployment inside the containerization platform. Okay. So I already explained you about ports. I already explained you about deployments. Now I'm going to the service portion. There our networking things are coming in. Okay. So basically we have three kind of services available. One is cluster IP, one is node port, another is a load balancer. Okay. So I will explain about what is the difference between these three. So cluster IP means something you need to communicate only internal. For example, you have an Amazon website, you're trying to deploy an Amazon website, and your Amazon website only need to expose the traffic for login page. So once you get inside the login page, your container, you have two containers. One is login container and other is the inside container. Inside things in cart container. I will name it as cart container. So you have two containers. One is login container, one is the cart container. So you don't want to expose your cart container to outside world. So people who are logging inside, this login container should expose to outside, and people who are connecting to this login page and able to log in, and this login container should communicate to the cart container, and one who are connecting to the login page and get authenticated should only communicate to the cart container. Okay, so in that case, your cart container should not be exposed to outside world. It should be exposed outside world only through this login container. So the communication between login container and the cart container, these two ports should be always internal. So there comes the cluster IP queues. The cluster IP will be giving the or configuring for the internal traffic. Okay, and node port. Node port is nothing but kind of an exposing outside kind of networking side, but we are using IP of the node. For example, we have so many VMs here, so we are using the IP of the VM, and we are using some port, some designated port. That port designation will be from 32,000 to 32,000, 7,700, something like that. 32,717, I think. So in that port range, you can configure a node port. And you can, if you deploy a node port, you can expose the traffic outside of your virtual machine, outside of your Kubernetes cluster, and access your application there. And we use the node port technology. And load balancer is completely different from these two, or we can say like load balancer is a combination of this cluster IP and node port. You can expose your traffic to outside world using load balancer. Also, you can communicate the port, internal ports, or internal communication using the load balancer. So I will just explain you about these three things with the help of a YAML file. Okay, that will give you more understanding. Coming to the services, I have created three YAML files: cluster IP, load balancer, and node port. Okay, so I have already deployed the application. This is already deployed. I cannot access this because I didn't deploy the service. If you go to the service option, I didn't deploy any service. So since I have deployed any service, this port cannot be exposed, or which cannot be accessed from outside world. I can only check this port. I can only expose this port using only one way. That is called that is called port forwarding. I can forward forward this particular traffic to outside world. I can check whether the port is working or not. I will use this port forward technology. I will click on this forward, and I will give some random port number 98989. Okay, 9898. That should be fine. And my traffic should be HTTPS. It is only HTTP. And I will give start. Once I give start, this lens tool will forward the port of this particular application, and it will check that whether my application hosted correctly or not. See, I can able to get a browser automatically from that lens tool, and it is trying to load some port there. Yeah, my application is getting loaded. Yeah, this is my application, which is having the upload option. Okay. So by port forwarding only, you can expose the application. Unless you didn't hosted your service, or unless you didn't deploy your service, you cannot expose your application. Okay. So right now, I tried this port forwarding only for showing you. I just want to delete this port forwarding. So just port forwarding is only for the purpose of exposing or checking how it is behaving. Okay. This is the port forwarding. I just want to stop this. Once I stop this, I cannot expose this. Refresh, it will kill. It's already killed. Yeah. So I cannot be reached. Now I just delete it. So that is the one way I can expose this particular port or the application. So that is a temporary way, or I can say that there's a kind of a troubleshooting way whether my application is hosted correctly or not. Second thing is the main thing is I need to write a service.yaml. So the service.yaml will be three types, which I already explained. One is cluster IP for internal trafficking, and node port is for external exposing. Load balancer is also for external exposing. Okay, I'll differentiate it. Cluster IP.yaml will be writing like this. I need to give the kind as service because it's a service file, and I have to give the type as cluster IP, and I have to give the port as 80 because it is hosting in HTTP. Okay, here you see that selector name as or the label name I have given as AKS image. So this is how it will understand that this service I am going to deploy for this application. So here you can see like my meta inside my app name labels, I have given my label name as AKS image. Okay, so this is how the service is getting connected. So understand that in a situation like I have 50 ports hosted, and this out of these 50 ports, 20 ports has to be internally routed, and 20 port or other 30 ports has to be outside exposed outside. So I have to write two service file. One is service cluster IP here.yaml, and one is the service load balancer.yaml. And this service cluster IP.yaml, I have to tag that which is my application name. So here comes the selector will play the role. This selector will say that which is the application I need to expose. Okay, so here I have given a selector as AKS image, and AKS image will go here and check that which is the deployment name. My deployment name is AKS image. So this will get do the networking part. Okay, so cluster IP is nothing but it's internal exposing. So internal kind of way of communicating. But comes into a node port. Node port is nothing. Node port is, I already told you that node port will assign an IP from the node or the VM, and it will assign a port. Like the same way we have tagged the port forwarding, the same way, kind of same principle, it will tag a port against that. But I already told you that port will be having some limitation like 30,000 to 37,000, something like that. I will, if I didn't mention this node port, any port number, it will automatically fetch a available port from there. And if I deploy this node port, or if I deploy this node port.yaml, I can expose my service using expose my traffic to outside world using the IP of the my node colon port number. Okay. And the third one is the load balancer. So load balancer is a common using one which we can expose outside. Node port is ideally using inside the AKS because if you want to expose a node or a VM, it is very difficult. Like we already deployed a VM in our internal traffic, and we need to expose a lot of things. So ideally we use, or the best practice, we will use the load balancer only. So I'm just showcasing you how we can deploy or expose our application using load balancer. Okay. In the load balancer, we will mention the service kind as service, type as load balancer, and we will give port as 80. And here comes, I already explained you, it is combination of cluster IP plus load balancer. So that's why I'm giving the load balancer node port. Okay, so this will expose easily. So I will just try, just deploy this load balancer quickly. So now I am in deployment folder. I have to go back. I have to go inside the services folder, cd space services. You can see service underscore lb.yaml. I will use kubectl minus f service underscore lb.yaml. Once I apply this, service got created. If I go to lens and check the service is getting created. It's in pending stage. Yeah, now it's active. So it took some time, right? So why it took some time? Because there comes the beauty of AKS. So AKS is doing some process background. So you can see in services, it is a type called a load balancer, and it has a cluster IP. I already told that load balancer is a combination of cluster IP plus plus node port. So it exposed a node port, and it is got an external IP. So once you copy this external IP, it automatically assign an external IP for us. Once you copy this external IP and put in the web browser, you can able to see the application got hosted. 20, 81, 59, 248. So 20, yeah. And I have to give HTTP in front. Yes, my application got hosted in the load balancer service right now. So here comes, we should understand this networking thing. So I can say that load balance is a combination of kind of cluster IP. So internal IP is assigned and it's exposed to a node port, and it can be taken from a load balancer. So what is the difference between load balancer and node port is nothing. I already said to you, like, it took some time to create, right? So if I go to the Kubernetes cluster or the AKS, in the MG resource group, MC resource group, the AKS will do two things. One is, we already seen a load balancer given there. There, it will automatically write two things. One is, if you check on the load balancer, this is my load balancer. If you go to the front-end IP, there was only one IP which I shown you earlier. Now one more IP came in, that is starting with 2081.59.248. This is the IP which is automatically created by the service called a load balancer, and this is automatically written by AKS. That is the first thing. That's why it took some time for getting it services get up and running. And second thing, you already know that it has to be exposed in the port 80. So we need to give a network rule that 80 port to be exposed, and it should only connect to this IP called 20 dot something. So if you come to the inbound rule, so you can see that a dynamic inbound rule has registered as a TCP protocol, and this IP is already registered there with using port 80. So that means this is actually doing by Kubernetes cluster. If you are not using AKS and if you are using a Kubernetes, you need to ideally create a load balancer, external load balancer like this, like the load balancer you've seen here. You need to create an external load balancer for hosting this, and you need to create all the network rules and all. Then only it will be exposed. So that is the main difference between cluster IP, node port, and load balancer. Node port you can simply expose using a real VM node IP and port, but load balancer you need a physical load balancer or an external load balancer, and Kubernetes AKS will perform all the role for you. You just need to deploy the file. Now your application got exposed. So that is with the networking side. And coming to storage, actually we have persistent volume or persistent volume claim. So I'll explain about what are these things are. So storage means, AKS storage means, so you know that your pod, for example, I have a pod, I already deployed a pod. My application is something which will store some images. That is my application, right? So you know that if you deploy something and if you upload something, your file will be initially get inside the pod. So what happens, like whenever this pod got restarted, all the files will be lost, and this is a volatile kind of keeping the memory. So we cannot trust the pod, and we cannot upload the files, or we cannot share data with that. So for example, my application is a data management application, and I have a lot of files to be uploaded. If I upload some files and if pod is keeping all my files, whenever a pod restart happened, all my files will be lost. So data stored will be completely volatile for this. Okay, that case we are using the storage class. Storage class or storage concept is nothing. We are using a physical storage, for example, storage account or a NFS server or a local storage account, anything, any storage or a data disk, anything we can use, any storage memory thing, we can allocate a storage using a storage class. So we should have three files for that. One is storage class.yaml, one is a persistent volume.yaml, and one is a persistent volume claim.yaml. So I will explain the concept of this. Okay, storage class means we are just mentioning about what is the storage class there. and which type of storage, which kind of storage we are using, or we are using a storage account, or we are using a disk kind of storage, and whatever it is, we are mentioning there. And inside the persistent volume, we are tagging the storage thing. Like for example, if we are using a storage account, a file storage we are using. Inside storage account, there will be file storage and blob storage. If we are using a file storage, we have to tag that particular file storage, and persistent volume will take care of that. Okay. And you know that the whole storage, for example, my storage data disk is, or my storage account is 1 TB. We don't require whole 1 TB for a pod. We require only specific portion of that to store my data for a particular pod. So there will be another option called persistent volume claim that will claim a particular amount of volume. For example, I only need 500 MB from this 1 TB. It will claim that 500 MB from this 1 TB, and it will attach to that to the pod. Okay, so you can see it from the diagram. I can use Azure Managed Disk as well as Azure Files. For this Azure Files or Azure Managed Disk, I will tag again as my persistent volume, and my persistent volume might be 1 TB. I don't need 1 TB for my pod. So what I will do, like I will dynamically claim 500 MB and I will assign again as my pod. And whenever my pod got deleted, it will again create a 500 MB and assign again as my pod. So whenever you upload some file to the pod, for example, in your application, if you are uploading some file, it will upload and it will keep inside the persistent volume or inside your data disk. The file will not be gone. Okay. So whenever the port got deleted, it will auto create next time. It will again take a 500 MB claim, and it will keep it as like with this port, and it will fetch that file from the storage location. So you will not miss the files. So that's why we are using in a 3 abstraction level manner: storage class, persistent volume, and persistent volume claim. Storage class will tell you the name and details of the storage account, and storage volume will be tagged against your storage account or your storage. And persistent volume claim will be allocate some storage to the storage you require. Okay, this is how the storage will be happening in. I'll be just quickly go through how the storage class YAMLs are written. So if you go to storage, okay. Storage, you can see like storage class.yaml I have written. In the storage class.yaml, I have mentioned that mine is a storage account, and my storage account name is this, and this is reside in this resource group, and this is a SKU name. RAGRS is a SKU name for that, and these are the writing technique or the mounting option, like 0777 is a permission, group permission, and file mode, or all those permission I am mentioning in the storage class. Okay, and this storage class have a name called sc-image, that is storage class-image. And then I will write a pv.yaml, and this pv.yaml, I will mention that this storage, this pv has to take storage from this storage class, sc-image. I already mentioned sc-image in this storage class.yaml, sc-image. And my storage class is totally 10 GB, and I need to create a claim. My claim name is image-pvc, persistent volume claim. And this image-pvc, I will write a separate pvc.yaml, and I am mentioning that it's should not be 10 GB. I'm mentioning that 1 GB has to be claimed from my total persistent volume or my storage account. So these 3 are interlinked. First, I will write a storage class, and I will mention the storage account details and all. Then I will mention that the total storage space and my storage class name, and the secret to connect to my storage account. What is the credential to connect to my storage account inside the PV, persistent volume. Then I will write a persistent volume claim. This persistent volume claim will reside inside a pod, and we will say that which is a persistent volume claim and how much GB has to be allocated across the pod. Okay, and PV does not have a namespace because PVC is a common one. PVC has a namespace because PVC is depend on a particular pod, so it should have a namespace. So these are the storage class technique we have to write. And last thing is the security. Security means we know that it is fully managed by Azure. So Azure is very secure. All the Azure security principle will be handled, and all the security patches will be handled by Azure security team or Azure Microsoft team. And main thing is like all the credentials you can save inside Azure Key Vault, and the same credential you can create as a Cube secret. So telling about Cube secret, so I have already written a Cube secret for you. So Cube secret, you need to write a Cube secret.yaml, and you need to deploy this Cube secret.yaml using cube apply -f the secret.yaml file. I have a storage account I already mentioned. I have written the storage account username and password using a secret.yaml, and this is base 64 encoded. I will take the file username of my storage account. I'll go to my Azure cloud. Okay. I'll go to my Azure cloud. Yeah. I'll go to my Azure cloud home. I think there is some network issue from my side. It's not loading it, but I can save. Like I can. Okay, so I'll go to my Azure Cloud Home. There, I can take my storage account. Inside my storage account, I can take the username and password of my storage account. So once I take my username and password of storage account, I can use some base64 encoding website, for example, base64encode.org, and I can put my credential here and encode it. For example, if my username is Rahul, and if I encode it, I'll get an encoding name, Rahul, and if I encode it, I'll get a corresponding encoding name here. Okay, and I have to put this encoding name here. So all the secrets will be encoded and kept it in a secret.yaml. And this secret I have mentioned as SA-secret, and this SA-secret is consuming inside the pv.yaml. You already seen that pv.yaml SA-secret is consumed. So this way the secret is getting stored. So I don't need to expose any of my sensitive secrets here. Azure is handling very well for the secret management thing. So these are the secret storage. Also, if I want to, I don't want to expose my secret data, or I have only variables to expose, and that's not a sensitive data, I can create a config map. Instead of creating a secret, I can create a config map. So the same way, I can create a config map, like I can write a config map.yaml. So in this config map.yaml, you can see like custom path is a variable, and path name is this. So this is the variable, and this is data. This should not be a sensitive data. So I can write any data here. Like for example, my application name, app name is image upload or image app. This should be stored as a variable name, as an environment variable name, and this variable name can be consumed inside anywhere. Okay, this is kind of storing some data inside Kubernetes cluster. Also, Kubernetes cluster can be used for private network allocation, so network security will be highly ensured. Coming into AKS and Active Directory implementation, when we created AKS, we already seen that we have an option to integrate Active Directory with AKS. So it will be easy for us to integrate AKS with Active Directory, and all the credential will be handling using AKS integrated security. All the RBAC rule we can mention there, and we can create a role binding there. Like for example, if we have two namespace, dev namespace and QA namespace, developer member should not able to access the QA namespace. We can create a role binding there, and we can give access accordingly with the help of this Active Directory. So it will be very helpful for us. And a future enhancement. So we already seen like I have written deployment.yaml, I have written service.yaml, I have written many YAML files for secret.yaml, many YAML file for storing this. Instead of writing all these YAML file, I can go with the help of help charts. And help chart is a templatized way of writing. There I need to manage only one single YAML file called values.yaml, and all other deployment.yaml, everything will be templatized and kept it in my Helm chart. I only have to enter the value inside my values.yaml. It will be more easy for me to deploy. For example, if I want to deploy an application right now, what I have to do, like I need to deploy the deployment.yaml, I need to deploy the service.yaml, I need to deploy secrets.yaml, I need to deploy the config map.yaml. Instead of deploying all those things, everything will be templatized and written in a Helm chart, and I only need to deploy the Helm chart. So for example, for I need to uninstall the application also, it will be very easy for me. So for the management thing, I can use Helm chart for all my controlling things, controlling application releases. Coming to ingress controller is another feature enhancement. So for explaining about ingress controller, I need to explain about what is an ingress. Ingress is nothing but ingress is also a way of networking kind of technique we are using here. For example, I already explained you, we have microservices, lot of microservices we are using here. For example, you have an application. In your application, you have home page. For whenever you are typing your myapp.com, you will be landing into a home page, and you want /upload or /about us. You have about us page, you have career page in your application, like that. So you can split the path or control the networking thing with respect to path with the help of this ingress controller. So for example, you are deployed 3 containers. One container is for home, one container is for /about us, one container is for /career. Okay, 3 containers you have. So in home, you don't need to mention about the path. You only need to mention that your path is / that is a home page. And for the other 2 containers, for your career and for your about us container, you have to mention, right, my path is /about us, and you need to tag the ingress against it. And for your career pod, you need to create one more ingress and configure /career address. For then only that ingress will route to the corresponding pod and corresponding application, you can hit it. Okay, so that is the main advantage of ingress. So ingress controller is nothing, it can handle the ingress. You might heard of Nginx ingress controller, application gateway ingress controller, that will balance the load, and that will try to ingress the traffic. For example, your application URL is https myapp/about us. So whenever you type this particular URL, it will understand that /about us if you give it. So it will check /about us in the URL, and it will take the /about us, and it will go to the ingress controller and check that where I am calling or which application I am calling. This ingress controller will talk to the ingress, and it will understand that my path is /about us, and it is mentioning about this particular pod, this particular application, and it will redirect to the particular pod. Okay, that is the main advantage of ingress controller, that routing mechanism, everything will be very easy. Also, you can deploy SSL certificate, very sensitive data as a secret, as a kube secret, like the same way which I have shown you. You need to write a secret.yaml, and you need to encrypt the credential like the CA cert and CA key. If you have, whenever you have a certificate, you need to pass that as secret, and you have to deploy it as a secret.yaml, and you need to point the secret dot files. For example, this is the secret for certificate. So you need to mention the ca.cert and ca.key here, and the credentials here, and you need to name your secret file as my certificate-secret, and you need to mention this certificate-secret while you are deploying the deployment.yaml. You can mention it here, like you can mention the secret here. Yeah, you need to add one more entry for tagging that particular secret. So that secret will be taking along with whenever your pod is getting up. So SSL certificate can be mounted there. Another thing is the horizontal port auto scaling. Horizontal port auto scaling means whenever you are getting a lot of loads or like kind of lot of hit in your application, you can increase the number of ports or replica state of your ports, and you can handle the port auto scaling things. Another is a scheduler. So scheduler we usually use for example, a use case I can say like when the after office hours you don't want these namespace need not to be up and running, you can shut down that particular namespace. For example, your developers, you have 10 developers, and those 10 developers are using separate namespace for their own testing purpose. So that namespaces should not need to up after office hours, because that is unwanted cost consumption. So you can create some schedulers and delete that particular namespace whenever the office time over, and you can reschedule to deploy that when they came back to the office hours. So those are the enhancement you can do on the schedulers thing. This there will be a lot of third-party schedulers which is available for these kind of activities. And if you have further questions or further things to be known, I can share my LinkedIn URL here in the chat. You can connect me offline also for any doubt clarification or anything.